So sound waves travel away from a vibrating source in 3 dimensions. So that means that these are spherical waves. These are like balls of sound waves that just erupt from whatever causing the vibrations. So if your object is right here in the middle, sound waves are going to travel in all 3 dimensions, circular around it or spherical around it. Okay? Because these waves travel like that, you end up with this thing called the Doppler effect. So the official definition for Doppler effect is a change in wavelength and frequency caused by the motion of the source or listener. Okay, now, honestly, the best way I have to explain this is a clip that we have from Big Bang Theory. So give Sheldon a shot at explaining this to you, because he does a really good job.
I want to talk to you about before we go to the party.
I don't care if anybody gets it. I'm going as the Doppler effect.
No, it's not.
If I have to, I can demonstrate. So what time does the costume parade start?
The parade?
Yeah, so the judges can give out the prizes for best costume. Most frightening, most authentic, most accurate visualization of a scientific principle.
Oh, Sheldon, I'm sorry, but there aren't going to be any parades or judges or prizes.
This party is just going to suck.
Oh, come on, it's going to be fun, and you all look great. I mean, look at you, Thor, and oh, Peter Pan, that's so cute.
Actually, Penny, he's wrong.
I'm Peter Pan!
And I got a handful of pixie dust with your name on it.
No, you don't. Hey, what's Sheldon supposed to be?
Oh, he's the Doppler effect.
Yes. It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
Oh, sure, I see it now, the Doppler effect. All right, I got a shower. You guys, make yourselves comfortable.
Okay.
See? People get it.
Hi.
Hi.
Hello.
So what are you supposed to be?
Me? I'll give you a hint.
A choo-choo train?
Close.
A brain-damaged choo-choo train?
I still don't get it.
I'm the Doppler effect.
Okay, if that is some sort of learning disability, I think it's very insensitive.
Why don't you just tell people you're a zebra?
Well, why don't you just tell people you're one of the 7 dwarves?
Because I'm Frodo.
Yes, well, I'm the Doppler effect.
Okay, so according to what Sheldon said,
Yes. It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
then therefore you can kind of put 2 and 2 together and you end up with the shorter the wavelength, the higher the frequency.
Yes. It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
Okay, so as it turns out, the Doppler effect actually comes in quite handy in real life. First of all, this is how speed radars worked. Whether it's a cop measuring how fast people are driving down the street, or it's a coach measuring how fast somebody can throw a fastball, that's exactly how the speed radars work. The other thing we have are echocardiograms. This is when they go in and they listen to the heart, and they can actually use the Doppler effect to see what the heart looks like. And then the other thing we have is a lot of Earth and space stuff that we do with it. Doppler effect causes red shift and blue shift. This allows us to see if things are moving closer to us or away from us. So if something is moving away from us, if it's moving away, the frequency gets longer. So it actually tends to shift to the red visible spectrum. So as the waves come apart, as the waves expand, you end up with a red shift to it. And so astronomers can actually use this to see if things are moving away from planet Earth, or the opposite of that, if it's coming at us or towards us, it's a blue shift. Because they get shorter in frequency. So this turns to get red. This turns to get blue. So you have red shift and blue shift. All right, thanks for joining me today. At this time, I would like for you to do a Dear Absent note card. And on your note card, explain to them what the Doppler effect is and name at least one thing that you can use the Doppler effect for in real life. Have a great day.
Yes. It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.